Welcome to today's class. In today's class, we will take problems on real gas or Vander Waals equation. Let us read the problem. Determine the pressure exerted by CO2, that is carbon dioxide. So, the given gas is carbon dioxide. So, let us note down that carbon dioxide in a container of 1.5 meter cube capacity. So, the volume is given 1.5 meter cube. When it contains 5 kg, so mass is given 5 kg at 27 degrees Celsius. So, the temperature of the gas is 27 degrees Celsius, but we are pretty sure when we are using these equations, the temperature has to be in absolute temperature, that is in Kelvin. So, let us add 273 here. So, temperature is 300 Kelvin. Now, we must determine the pressure exerted by CO2 by two equations, that is, one is first question ideal gas equation, the second one is Vander Waals equation. So, we will take the first question. PV is equal to MRT is the ideal gas equation which we know. Okay. So, we are interested in finding out the pressure. So, pressure is equal to, let us say, I will send everything to the right side, MRT by V. Mass is known to us 5 kg. R value will find out. Volume is 1.5 meter cube and the temperature is 300 Kelvin. Now, how do we find out the value of R? The value of R has to be determined by the equation R bar by molecular weight of carbon dioxide. Now, R for carbon dioxide has to be determined by the trick R bar by molecular weight of CO2. Now, this is there in the equation data handbook. You can find out from BT Nijaguna data handbook, thermodynamic data handbook by BT Nijaguna. We have this table C10. So, in that we have all gases listed here and their molecular weight listed here. We are looking for carbon dioxide. So, carbon dioxide has 44 kg per kg mole of molecular weight. So, denominator we have got 44. And the value of R bar is a universal gas constant. Either you can choose to remember or it is also mentioned in first few pages of the same data handbook, 8.314 kilojoule per kg. So, I am writing it in joule here. So, it is 8314. So, value of R for CO2 is 8314 divided by 44. So, 188.95. 188.95 joule per kg Kelvin. So, this is the value of R for carbon dioxide. Now, let us substitute this here, 188.95. Now, let us find out the pressure exerted by carbon dioxide. 188.95 into 300 divided by 1.5. So, 188.95 into 10 power 3. 188.95 into 10 power 3 is the pressure in Newton per meter square. Or if you divide this by 1000, you can write it in 188.95 kilopascal. Okay. So, this is by ideal gas equation. Same pressure can be found out using Vander Waals equation as well. Now, Vander Waals equation is also present in the data handbook in page number 59. You can see here. I have tried to copy the page here. So, we have this equation P plus A by V bar square into V bar minus B is equal to R bar T. Okay. So, pressure is what we want to determine plus. Now, the value of A and B has to be copied from the data handbook. So, value of A and B is in table C8. Value of A and B is in table C8. So, we are looking for carbon dioxide. So, it is here. The value of A is 365.6. The value of A is 365.6. As we said, it has to be multiplied with 10 power 3, so that it has to be Newton meter power 4 kg mole square. Okay. And the value of B is 0.0428. The value of B is 0.0428. The value of B is 0.0428 meter cube per kg mole. The unit is at the top. You can see here. Okay. So, the value of A will substitute 365.6 into 10 power 3, and value of V bar. Remember, how do we calculate V bar? V into molecular weight. Now, V is, we know the value of V, specific volume, is volume by mass, small m. So, volume was 1.5 and mass is 5 kg. So, we will have 1.5 by 0.3. So, specific volume is 0.3 meter cube per kg. So, specific volume is 0.3 and molecular weight is 44. So, the value of V bar we can find out. Value of V bar we can find out. 0.3 multiplied by 44. 13.2. 13.2 meter cube per kg mole. So, 13.2 square V bar square multiplied by V bar minus B. So, B is 0.0428 is equal to R bar 8314 multiplied by temperature is 300. So, the only unknown is pressure here. So, we must be able to find out the value of pressure. And remember, this value of pressure will be very close to here. We know these correction factors include intermolecular forces and volume of each molecule. So, the answer will not be too different, it will be closer to the same answer. So, let us solve this equation. So, I will take the unknown as x. So, alpha x plus 365.6 multiplied by 10 power 3 divided by 13.2 square into 13.2 minus 0.0428. So, alpha equals 8314 into 300. So, we will solve, shift, solve for x is equal to 0 and say equal. So, you can see the answer is 187.47 into 10 power 3 Newton per meter square, which is nothing but 187.47 kilopascal. So, that is what we said, the answer will be very closer to the ideal gas answer. So, you can always verify the answer which you get from here. If it is closer to this, probably you are right. Okay. So, let us take one more problem. So, we have Same problem, determine the pressure exerted by carbon dioxide in a container of 1.5 meter cube capacity and 5 kg 27 degrees Celsius. The data is same, but the values of A, the values of B and R bar values are given to you. So, this is similar to last problem, but values of A and B are given to us. We need not to refer data handbook. So, values of A and B are given. Okay. So, let us take one more problem then. Compute the pressure of argon. So, the value of argon has to be seen if at all you are referring to data handbook. So, argon is the gas at a temperature of 425 degrees Celsius. So, temperature is 425. So, we know that the temperature has to be in Kelvin. So, we will have 698 Kelvin. Okay. Temperature is 698 Kelvin. Specific volume, directly specific volume is given 0.0115 meter cube per kg. So, we will have to find out the pressure by Vander Waals equation. That is what he is saying. So, find out pressure by Vander Waals equation. Take A is equal to, so the value of A and B are given. Anyhow, our data handbook does not list the argon gas here. So, value of A and B are given. Very good. So, A value is 0.1376 Newton meter power 4 by kg mole square or kilomole square. Both are same here. So, the value of B is given 0.0320 meter cube per kg mole or kilomole. And molecular weight of this gas is also given 40. Alright. So, we will copy the equation from here, or if you remember, that is also good. So, Vander Waals equation is given by P plus A by V bar square into V bar minus B is equal to R bar T. Okay, V bar we will have to find out. I will find out V bar here. V bar is equal to specific volume into molecular weight. So, specific volume is 0.0115 and molecular weight is 40. So, let us find out the value of V bar. 0.0115 multiplied by 40. So, we will have 0.46 meter cube per kg mole or kilomole. So, we will solve this equation now. P is the unknown, A is given in Newton meter power 4, so 0.1376 divided by V bar square, that is 0.46 square into 0.46, that is V bar, minus B is 0.0320 and R bar is 8314 multiplied by temperature is 698 Kelvin. Okay. So, unknown will keep it as alpha x plus 0.1376 divided by 0.46 square okay 0.46 minus 0.0320 alpha equals 8314 multiplied by 698. So, we'll shift solve for x is equal to 0. So, we have the answer 13.5, pressure is 13.55 into 10 power 6 Newton per meter square, or we can say pressure is 13.55 kilopascal, sorry, megapascal. So, if we have doubt about this answer, we can always verify by PV is equal to MRT equation. Okay. So, the ideal gas equation is PV bar is equal to R bar T. So, by this method also we will verify. Anyway, we have V bar value, so 0.46 and R bar is 8314 and temperature is 698. So, the answer should be at least closer to this answer. So, we are just verifying it even though it is not asked for us. So, alpha x multiplied by 0.46 alpha equals 8314 multiplied by 698. Shift solve for x is equal to 0. Okay, we are getting answer 12.61 into 10 power 6. So, which is closer. So, we can say 12.61 megapascal. So, we can always verify these two answers should be quite nearest. All right. Thank you.